So we are starting our session. Alrighty. So thank you so much. And like I said, um, we will be dealing with data analysis tonight, and we're also going to be looking at several issues that help or will help you as you do your data analysis. Okay. So in this session, I want you to be, just focus. That's all I'm requesting from you. Just focus so that we can move swiftly and nicely together. So when you're dealing with data analysis, and welcome to everybody, by the way, my name is Dr. Alex Malapane, aka Dr. Bay. If you join in here on TikTok, but in other platforms, you will find me as Dr. Alex. So before we can continue, I think in the last week specifically, we dealt a couple of issues, especially we dealt with how do you write a literature review, how do you write a proposal, a methodology, and we also dealt with a couple of issues pertaining to research. So one of the most important part and parcel of research is the component where now you have to do data analysis, because at the end of the day, your study or your findings of your study will be coming from um, the analysis. So the analysis that you will do to get the results, and then from the results, you bring the findings, because there's a slight difference between the results and the findings. And the discussion on how do you analyze the type of data is also a little bit different. So it depends on on a couple of things and a couple of issues. So I want you to then look at. We're gonna discuss, for example, on these three type of um, method which are applicable to social sciences, which is your qualitative, your quantitative, and your mixed approach. Which method is proper for your research, and we're also going to talk about what kind of analysis can you do within each of these three types of research methods or approach. So as you work through, as you learn in this session, you got to differentiate the type of tests that are going to be needed or required for your, for example, qualitative, and also what will be required for your quantitative. So most of the common mistakes students make, more especially the reason why your proposal, you will do your proposal until version number 10 and it keeps getting rejected, is because so many students do not know how to differentiate between analysis that are required for qualitative and analysis that are required for things like your quantitative. And at the end of the day, there's a whole lot of issues that affect students, and they end up being depressed. Some, they feel like their lecturers are unreasonable and all that. But the key issue is that there is no way in which your proposal will be accepted, especially if your data analysis is not properly written, what you're proposing as your data analysis. So data analysis is a systematic process of organizing, examining, interpreting, and making sense of your data, from your research data, for example, so that you can, so that the researcher or yourself can answer research question and achieve research objectives. So research reflect evidence, and data analysis turn evidence into answers, in short, or in layman terms. So it's very important for you to understand these issues and also understand how the difference is. So the analysis method must be determined by the research questions. It's not determined by what you like, or what you are used to, or what your friends have told you. It has to always be in line with your research questions, objectives, research design, the type of data, and the level of measurement which is going to be used, so that you should be able to then achieve your research objective. So researchers should never, for example, choose an analysis simply because it is popular, or because they know how to use it, or to use the software that is associated with that. they have to use anything that is relevant and appropriate for the study, because it's not everything that is appropriate for any kind of a study. So research analysis or data analysis in research is very strict, because if you don't put it properly, you'll realize at the end of the day you might collect data that is irrelevant, and you are not able to either perform the test or perform the analysis that is required, because there was something technically wrong with how your structure is. So there are three main approaches which I've always talk about, or I just mentioned, but I will keep mentioning so that you understand the difference between these terminologies. So the first approach is quantitative, which use the type of data that you use is numerical data. So these are number driven type of an approach. The main purpose is to measure, compare, predict. And the common analysis in this method or in this approach is descriptive and inferential statistics. Now, on your qualitative, you have what we call, for example, is textual, verbal, and visual. So here, the main purpose for you is to understand, for example, the experiences, the meaning, and processes. And then, the common analysis that I can mention in passing is your thematic analysis, as an example, content analysis, narrative analysis, discourse analysis. Those are the things that you really need to understand, especially if you are working on qualitative research. Now, when you're working on the third type of approach, which is called mixed method, here you are now mixing numerical and qualitative. So it means numbers and non-numbers, or numerical and non-numerical numbers. So all these two, when you combine together, is a mixed approach. But there's something very important, because the purpose of a mixed approach, it means you want to integrate measurements with deeper explanation, for example. So the common analysis here is statistical plus qualitative analysis plus integration, because at the end of the day, you will need to integrate the data or the findings of your study into the third phase. And if you remember, when I was here discussing about the methodology, we spoke about different type of methodology, and we based those methodology. And I gave you, for example, the type of design that is required. I also told you about the type of the design that are there from qualitative, quantitative, and mixed approach. And I spoke about explanatory um, design for qualitative research, and I also told you about explanatory design, which is strictly for your quantitative method or approach. And I also spoke about the mixed method one, where we talk about, for example, the sequential ones, where we start about exploratory, sequential. By that we mean, if it's exploratory, it means the first phase, because it will have three phases. The first phase will be qualitative, followed by quantitative, and then the last phase will be integration. So you will always require integration in a mixed approach. But how, or the first sequence, especially if it's sequential, it is determined by the type of the study. So if the type of the study is exploratory, it will start with qualitative, then quantitative, then the third one will be integration. But if the study, if it's a explanatory sequential design or sequential method, then you start with quantitative as the first phase. Then the second phase will then be qualitative, and the third phase, of course, will be integration. And then we've got what we call convergence parallel method, where you now have only two phases. Why? Because the qualitative and the quantitative are happening at the same time, which is phase one, and then of course integration at the end, or the second phase will be integration. And then you will have the fourth part, which is called the fourth part will actually be you choose one, and then the other one becomes complementary, and then you have integration. So those four, they give you for example, what is required and the type of the flow in terms of mixed approach. So it's very much important for you to understand those things, and understand also the type of integration, or the second, in terms of how you've chosen your mixed method, which is integration. So quantitative data analysis, what is that? Quantitative data analysis involves analyzing numerical data using statistical techniques. Example, questionnaire responses, test scores, financial figures, economic indicators, performance measures, experimental, measurement, and secondary statistical data sets. And what is secondary statistical data sets? These are stats or information that is already been out there in the public. You don't have to collect it for your study. So it's already existing, it's there. You can simply go and find it and kick off your study or kick off your analysis because the data is already there. So you can check the data, prepare it, and do your statistical test, for example. But what we call by primary data, all these other ones, questionnaire response, test scores, and everything will have to be collected by you as a primary data. It's different from secondary data because secondary data already exists. The data sets already exist. So the difference between the two is that the other one, data is already available, which is secondary data, and the other one you will have to collect data, for the very first time as a researcher for your study. Okay. Don't forget, we are streaming your dual tonight. We are both on TikTok and we're also both on YouTube. But I will give you the link for YouTube immediately when we are done. I will post it on my wall so that you will be able to find it. But the most important thing for you is to understand the difference between these things, right? And another thing that you need to know is the different type. And I will go back. I will go a little bit deeper so that you understand the flow. So researchers in quantitative analysis normally go from raw data, whether you have collected primary or secondary data. They do the data cleaning because sometimes there may be entries that are not proper or there are entries that are missing or whatever. There's missing data whatsoever. So you cannot put a spreadsheet, for example, in SPSS that has missing data and all that. You will get errors when you're trying to analyze your data. So you clean your data. After cleaning your data, you code it properly and then you do the descriptive, for example, analysis. I told you about the type of the descriptive analysis, and I spoke about the mean, the frequencies, the percentages, the modes, and all of that. That is descriptive analysis or descriptive data. From there, you do your inferential analysis, then interpretation and finding. That is quantitative. And for you to understand or to flow in quantitative, there are so many things. I'm going to give you step number one that you do. The step number one that you need to go through is data cleaning and data preparation is very important. Never jump into regression, ANOVA, or even hypothesis testing without checking one, missing values, duplicate observations, incorrect coding, outliers. What are the outliers? For example, your scale, you're using a Likert scale of 1 to 5. And by some hook or crook, you find that your data has 6, 7, 8. Those are outliers because they are not part and parcel of your measurement scale, for example. Impossible values, I just explained one of the impossible values. Data entry errors, for example. Reverse coded questionnaire item. Variable labels within your numerical data. Measurement level within your to check if the scale that was used is it proper, because you have got ordinal numbers, you have got numerical and different type of data within the quantitative analysis space. So there are so many things I can tell you about that. Then when you go to your descriptive, for example, statistics. So descriptive statistics describe the statistics and describe the sample and the data. So it's the frequencies that I told you about and percentages. So this is useful for categorical variables. Why? Because for you, in order to measure a certain thing or to be able to come up with statistics for a certain thing, there must be linked and interlinked to a correct for example, measurement scale. I already spoken about that, and you must be able to find the frequencies and the percentages so that you are able to quantify some of these things. Measures of central tendency are also important. What are these? The mean, which looks at the average. You've got the median, which looks at the middle value, for example. the modes, which is the most frequently occurring value. And you will understand this as we continue. So the measures of dispersion, for example, they look at the range, the variance, and the standard deviation. If your study, for example, only report frequencies, percentages, mean, you have actually tested relationship or differences. So usually, descriptive statistics tell us the data, you know, the data that you look, what the data looks like. Inferential statistics allow us to investigate relationships, differences, effects, and predictions. So it's very important for you to understand these things as you move, so that if you have a question, we will tackle it quickly. But I want to stop at step number 3 and then take questions that are there. Then we can continue. Then the third step is what we call inferential statistics within the quantitative analysis. This is where most postgraduate, become confused, and I must say it. Why? Because the statistical test must match the research questions. There's no way in which you're going to test a certain thing that is relevant or irrelevant to your or it's off target from your research question. So it must always be linked, or it must always be relevant for your research question. I will repeat again. So many students are confused and make mistakes when it comes to understanding the statistical test that must match exactly with their research questions. Research intentions, I will give you examples and possible technique that you can use. Determining association between categorical variables, you will have to do what we call chi-squared. If you are comparing two means, it's called t-test. If you are comparing 3 or more means, it's ANOVA. Remember, I will repeat. If you're comparing 2 means, it's t-test. If you're comparing 3 or more means, it's ANOVA. You know, if you are examining the relationship between continuous variable, is correlation. Remember the terms, they are very important. If you want to predict a continuous outcome, is linear regression. If you want to predict a binary outcome, it's called logistic regression. If you want to analyze repeated observation over time, for example, either in a time series space and all that, you will then have to do repeated measures or longitudinal techniques. If you want to analyze multiple related variables, then you use, or the technique is called multivariate techniques. Okay, I will stop here and take questions. Remember, if you need personalized one-on-one or either coaching or research consulting or even statistics, you can take my number on the screen. There's 079 double five double seven six is 079 745577 Then you can approach me and talk to me if you require statistical analysis or data analysis, especially for masters and PhDs, even for honors, or maybe if you are looking, for example, for research consulting or services where you want one-on-one session and all that, you can also DM here on TikTok. I'm going to stop here for a while, a little bit, so let me take questions so that we can have some engagement. And thank you for the follow. Those who have been here for the very first time, please do follow me and make sure that you like the live and share the live. Metemri says, explain theoretical framework, concept theory. What should I contribute as a research? Okay, that is off target to what we are discussing now. Specifically for now, we can talk about those things a little bit the other day or sometime. But today we are strictly on data analysis. So I don't want us to mix things and people don't follow. Please, all your questions today or your questions and engagement must be solely based on data analysis, so that when you have others, we can pack them until we have such a session. Or you can, if it's a burning issue, you can take the number on the screen, or you can actually DM me so that we can talk about it. All right. I just don't want to confuse everybody who's here. And thanks to everybody who's here for the very first time. Um, Let me see if there's another question. The aspiring doctor says, where lies the difference between ANOVA and contingency on inferential statistics instruments? Okay, we'll talk about those things. You just follow through the live. We will touch on them. Now, what I want you to now look at, I pressed something by error. I'm not inviting you. Please decline that. One of the issues that we need to understand is before you can actually set up your data collection instrument, and you can finalize it and go and collect your data, you must understand what kind of statistical tests are required for your research problem and objectives so that your statement and questions will be able to answer, or they will be able to make statistical um, test to be possible. So if you are going to just look at, creating a survey, and you find that at the end of the day, the survey doesn't merge with the research objective, then there's going to be problems. So you need to make sure there's that alignment. That is why it's very important for masters and PhD students, especially, to go and look for services of a statistician for you to be helped on how to construct. Or when you have constructed your draft, please go to a statistician for them to take a look at your instrument before you go and collect data. The danger is you might collect data that is not relevant to your study, and you spend like the whole year collecting that data, and at the end of the data is not user friendly. It's just garbage that has been collected because it's off target from your research objective and cannot perform or cannot comply with the required statistical tests that are required for your study. One of the critical lessons, the study will use SPSS to analyze the data. Do not write something like that. This is incomplete. You got to say, for example, SPSS is a software. It's not an analysis method. It's a software you use to analyze the data. So rather explain in your study, or rather understand that quantitative data will be analyzed using, for example, descriptive and inferential statistic techniques. So the techniques are what? Descriptive and inferential statistics. But SPSS is a software you use to analyze. So the technique is descriptive and inferential statistics, which are the statistical technique, but the software that you want to use to analyze the data is then SPSS, Starter, eViews, for example, if you are doing economic research or you're doing econometrics and stuff like that. So it's very important for you to understand this and differentiate between a statistical software and the statistical technique. Descriptive statistics, for example, will summarize characteristics of the sample, while appropriate inferential technique will be used to examine relationships or differences relevant to the research objective. Like I said, inferential statistics, and I mentioned a couple of inferential statistics that you can look at, or you need to look at, and the possible techniques. So the possible techniques, remember I told you, is what? Is things like the chi-square, t-test, ANOVA, correlation, linear regression, logistic regression, repeated measure, or longitudinal techniques, and multivariate techniques. Those are the example of the techniques. And I just gave you an example, the difference between a software, like the use of IBM SPSS statistic tool or software, compared to a what we call statistical technique. So those are the two things that are very different and should not be confused as one. The next thing that you need to look at now, within the quantitative space, you need to look at the correlation, because we've got what we call correlation versus regression. Students regularly, in most cases, confuse the difference between correlation and regression. Correlation, for example, ask, are Y, maybe for example, is X and Y related? So correlation will then provides information about the strength and the direction of association. Remember, correlation does not automatically establish causation. Regression will then ask, as an example, what does X explain or predict y, controlling, for valuable, for variables included in the model. So you've got two things now that are a little bit confusing. You've got correlation and you've got regression. Correlation tells you, are X and Y related? If it's a problem or whatever, you look at the variables, you look at them, are they, related? But then when you talk about regression, you then, to what extent does Y explain or predict Y? So, for example, if you want to look at employee motivation associated with job satisfaction, you then look at those things and say, are these things really predicting job satisfaction? For example, is employee motivation associated or predict or explain job satisfaction? Because for somebody it could be related to salary increase or being paid properly. For other one it could be related to something else. For other one could be related to something else. So you're trying to find the relationship between the two. So don't confuse correlation and don't confuse regression. That's what it means. Okay, I see a popping message here. I just want to quickly see what it's all about and then I'll be back here. Sorry for that. So as we move along, it's very also important for you to know how to structure your your statistical tests that are required based on how your research objectives are structured compared to what are the expected outcomes from your research objectives. So you must always keep in mind, how are you going to do that? So for example, if you want to then work on regression, the example that I can give you is, to what extent, for example, does leadership style predict employee performance? And then you use a model for that. So I wouldn't go to the models and all that, because that's a deep statistic language and equations which will confuse you more. But the most important thing for you is, if you're doing masters and PhD and you are now doing data analysis for quantitative research or quantitative phase, you need to get services of a statistician to guide you and also to perform some of the tests for you, because some of these things, for you to just learn SPSS, it can take you a year to master it. So you don't have time to be going through to that software and trying to understand and all that. You just need to hit the ground running. They will give you the results, then you go and do analysis on your own. And then we have got what we call hypothesis testing. So many students get so confused. What is hypothesis? Why do we have to test for hypothesis, as an example? So hypothesis testing is relevant and equivalent, it's relevant and aligned to the quantitative study. So in the qualitative study, we do not do hypothesis testing. There are so many times where you find a proposal written by a PhD student mentioning it's a qualitative study, but there is somewhere where they're talking about testing for hypothesis. So you have to differentiate. You need to know what is relevant for this and what is relevant for the next, for the other part. Hypothesis testing is only for quantitative study. So hypothesis, or typically what hypothesis mean is, you have got what we call a nil hypothesis, and then you have got a positive, or a hypothesis maybe one moving above. So A to zero or nil hypothesis tells you that there is no statistically significant relationship between X and Y, as an example. Whereas H1 will then tells you that there is a statistically significant relationship between X and Y. But again, I won't go deeper on these things because you will be confused forever. It's a language of statistician. Let it be handled by the statistician. They will then explain to you what it means so that you can do your analysis properly. They can do your data analysis for you, and then you do your interpretation properly. So statistical significance is not the same as practical importance. So many students, for example, come up with, they don't know how to structure, for example, information or analyze the information that comes from a quantitative perspective. Because from a quantitative perspective, you got to understand that quantitative, in general, the analysis will look like something where, if it's a mixed approach, for example, there will be causation, because now you are comparing the statistical pattern with the, not necessarily the pattern or the finding with the qualitative findings. And sometimes, you know, generalization is used, especially in quantitative research or quantitative methods, because we generalize based on probabilistic issues or from the probability of an issue. And I always give an example that you will find that saying, for example, 1 in 5 people is HIV positive. That is um, a generalized statement that comes from quantitative data. Sometimes they will say 1 in 5 people is employed and 4 in 5 are unemployed. So those are generalized statements that comes from what we call quantitative data, because it's number driven. So you can make those generalization if your data has shown you that indeed 1 in 5, for example, is either HIV positive, is either employed, or whatever the stats could be. So I'm just giving you example with things that are commonly known and commonly understood. Oh, by the way, you can also send a gift here. There are no gifters here. I don't understand. Please do interact and do give some gifts here so that I can be motivated. So statistical, again, a tiny effect can be statistically significant in a large sample, in a very large sample. So it's very important for you to keep those things in check and in reality. I think you guys, you now know the kind of gift that I like. So I like that heart thing. If you give me that one, I will be flowing, trust me. So researchers or students should therefore consider effect size, confidence intervals, and substantive meaning where appropriate, especially when they are doing quantitative study. So we have got what we call reliability and scale analysis that is found within a quantitative angle. So for questionnaires containing, for example, multi-item scales, researchers may assess, internal consistency. Commonly used measures in statistic one is called what you call Cronbach alpha. So it is important that you understand what a Cronbach alpha means and what is it tests. So it tests reliability. So a commonly used tool for you to test for reliability. So reliability must be interpreted in line with the instrument, construct, number of of items, and context. Generally, reliable number is 0.7 Cronbach alpha, but that is not a globally accepted number, or it must not be regarded as the gospel truth, because you still need to look at, for example, the instrument itself, construct, number of items, and context in which Cronbach alpha was measured. Now we have what we call, again, within the quantitative space, quantitative assumptions. What are quantitative assumptions? Before certain statistical tests, researchers may need to examine assumptions such as normality. You can also assess or examine things like your independence, appropriate measurement level, and the likes. There are many, but I'm just giving you an example. So do not run regression because your supervisor said do regression. First, establish whether regression is appropriate for the data and the research question. So it must always be aligned, because you don't just, like I said, you don't just wake up and start doing data analysis and then you decide, oh, I'm going to do regression. No, no, no. You must first establish, is regression, for example, appropriate for the data and the research question that I'm treating. And remember, do not confuse what I told you, regression and what? Correlation. Now, let's talk about the softwares that you can use to do data analysis in or in quantitative approach. You can make use of a starter. It's one of the statistical tool. You can make use of IBM SPSS statistical software, which is commonly referred to as Statistical Package for Social Sciences, SPSS. And then you can work on e-views, especially if you're doing econometrics as an example. There are so many. You can use R, which use a coding language. You can use Python. You can use Power BI, and all. There are so many softwares. It always has to be aligned with the type of test that you need to conduct. For example, there's an extension of AMOS that comes from SPSS. It also used to measure some other things. It's not meant for anything else, but it also measures some other component within, or do some other test or statistical test. So have an appropriate type of a research software or statistical software relevant for your statistical tests. Okay, let me quickly look at the test. Then, the questions, if they are there, then we will take from there. What is the purpose of EFA? Okay, guys, I think I want you to be focused now, because remember, I'm live both on TikTok and also live on YouTube. So your questions should be relevant to what I'm talking about. We will deal with other issues, more specifically where we are dealing about the EFA, we're dealing about deep analysis, especially from a statistical point of view. Right now, I'm giving an overview and not necessarily deep statistics, because once I start mixing these things and all that, the flow and how it should be, you're going to get lost. So if you have a specific question that requires a specific attention and is not relevant to the content, please just send me a DM or send me a WhatsApp. We can talk about it differently. But for now, I want people to be, because this is a class and it's live. I'm live already. So I cannot be going back and forth and taking things that are irrelevant to what I'm discussing. And I know as a lecturer and as a professional that mixing some of these things will take you off. I can even throw most of you off the bus because of trying to explain so many things that are different and differently packaged, or are supposed to be differently tackled. So I'm going to look for a question that is relevant to what I'm discussing, then we take it from there. Other questions, we can take them when I'm not live on YouTube, so that the content is coherent, is proper, and aligned. I hope you get it. And Paul, thank you for the rose. I saw a rose there. Thank you for the gift there. How can I contact you? There's the number on the screen, and you can also DM me here on TikTok. Let me see if there's another question. You can bank some of this question for later, or when we have a free session where you're just asking any other type of question you have and all that, then we can take it from there. But if you are bringing distorted questions that are drifting away from the pattern and how the lesson is composed for tonight, it's going to be a little bit problematic. I'm just thinking for everybody who's here so that we can, move together. I always tackle all questions, but since you requested that I now go hybrid, then I have to be I need to take cognizant of some of the stuff and how I package my information for flow perspective, or for flow sake. For example, I cannot term my life something else, and then when a person goes and try and look at and watch the video, they find me all over the place. That's what I'm trying to guard against. I hope you understand that. I'm still going to come back and assist you with those questions, but we just need to be out of the comfort of YouTube, so that the content is stacked properly. I'm not going to read any other comment that is off target from my topic, so that we remain professional. Now let me go to part number B, which now deals with the qualitative data analysis. And what is a qualitative data analysis? Let's start there. For example, remember I told you that qualitative data is simply non-numerical data. So it's not numbers. We're looking at experiences, we look at perceptions, we look at meanings, we look at practice, processes, context, interpretation. So it's a little bit different, and it's stacked differently. Even the data, how you collect the data, how you analyze the data, how you present the data is totally different from the component that you find, for example, in the quantitative strand or in the quantitative approach. Okay, so it's very important for us to really follow and make sure that we are coherent. Now, what are the type of data, or the data? What does the data looks like, or what does it include? It includes interviews. That's where now you go and do interviews for your qualitative data. The qualitative study. It looks at the issues of interviews, focus groups, documents, observation notes, open-ended questionnaires, responses, for example, policy documents, if you are doing research related to policy, reports, archival material, even other, for example, the type of data. Even in the qualitative, you still have two types of data collection. I mean, sorry, not data collection. You can have what we call primary data collection, which is where you're going to do the interviews and all that. And you can have secondary data where you are using archival material, reports, policies that are already existing. You're also looking at maybe websites and information that has been gathered by either organizations or open that there's data also that comes from open sources, reports, and other stuff. And if you are doing document analysis, for example, you will go and do a systematic literature review, as an example, where you collect a whole number of documents, a whole number of journals for your study. Okay, so the basic movement is, or the line is, it's raw qualitative data, whether secondary or primary. Familiarization, where you now look at the data and try and understand what the data is all about, the coding part of it. And then you go to categorization, or categories and patterns, then themes, especially if you are doing thematic analysis or any other analytical output, then interpretation and findings. That is the key basic movement of how you start from the raw data until you come to your findings or you finalize your analysis. Now, the most important part, or the one of the most important part within the qualitative analysis space, is coding. Coding involves identifying and labeling meaningful features of the data. For example, if you are doing, you are doing interviews, how you anonymize people, that is coding, because you might give a code that represent a certain respondent, for example. You're giving codes. You're giving things like, from codes, you're giving things like, as an example, um, you are also looking at anonymizing the participant. You are also coding how the categories will look like and all that. So the coding is very important. An example within an interview statement will be: management introduce policies without consulting employees and make, for example, this and make and this makes implementation difficulties. So possible codes will be: one, you could be coding limited employee consultation as one issue. You could be coding, for example, top-down decision making as one issue. You could be coding implementation difficulties as another thing. Remember, the coding and how you code in within the qualitative is very much important in your analysis, because once you start your analysis and you start dealing with other things, you will be able to then categorize, you'll be able to even do subgroup, you will even begin to compare and others, because your coding is consistent and it's proper for your analysis. So multiple related codes may eventually contribute to broader analytical category or theme. For example, participatory governance challenges as one of your code. Now, one of the most used or loved or well-known data analysis in quantitative is referred to, or is called, um, thematic analysis. So I want to pay a little bit attention on thematic analysis. So thematic analysis is widely used in postgraduate qualitative research. A commonly applied approach is brought by two people called Brown and Clark, who has brought what we call six-phase process. Now, this process, number one, it talks to the familiarization of the data. Second one, it talks about generating of initial codes. I just spoke about how you generate codes. Then it talks to generating or searching for themes, for example, reviewing and developing themes. And then the next step, or step number 5, defining and naming the themes, and also producing the report. So importantly, a theme is not simply an interview question. So you don't take a research question and then put it as or interview question, sorry, and put it as a theme. No, theme is for example, a bad theme will be: what challenges do employee experience? That is not a theme. So a better theme will be something like institutional resource constraint, because a theme should represent a meaningful pattern in the data relevant to the research question, and not necessarily taking the research question exactly um, as a theme. All right. Uh, all right. Thank you for the rose, Joyce. There, Joyce sent me a rose. Thank you so much. Other qualitative analysis approach, which I will not go deeper, but I will just mention them, for example, for your sake, so that you know that it's not only thematic analysis. Normally, people who come to me who are doing qualitative, 99% of them, they want to use thematic analysis. Sometimes I ask a question, why? And the student doesn't even know why they chose thematic analysis. They just like thematic analysis. They just found it somewhere mentioned as thematic analysis, and they feel that's something that they need to go with. No, it doesn't work like that. There are so many other type of analysis within the qualitative space, especially if you are not going to be using interviews and all that. So you must understand that it's not only um, thematic analysis, there are other analysis. I'll give an example. There is what we call content analysis. What does content analysis look at? It examines and systematically categorize contents, useful for documents if you're doing documents analysis, useful for written responses, use for example, media content, reports, and policies. There is what we call narrative analysis, which focuses on how individuals construct and communicate experience through stories, which is different from thematic analysis and also content analysis. You've got discourse analysis, which examine language, meaning, power, social construction, as an example. You have got grounded theory analysis that looks at iterative coding and constant comparison to develop, grounded theory in data. Remember some of these things. The grounded theory that you can only, I mean, that you're working on can only be analyzed through, grounded theory analysis. You've got phenomenological analysis. I know this term always, I don't get it correct, and you always laugh at me, which explore the meaning and the structure of lived experience. And then you've got what we call qualitative data analysis, document analysis, which systematically examine documents to identify evidence, patterns, meaning, relationship relevant to the research question. So in most cases, this will be your data analysis method or strategies within the qualitative. So it's not only thematic analysis. I wish one day I would be helping a student and I don't find thematic analysis anywhere mentioned, especially if they are doing qualitative research. So your qualitative analysis, as an example, uh, analysis method must fit with your research design and analytical purpose. Do not automatically write thematic analysis simply because the study is qualitative. Okay. Thank you for the rose there, Joyce. Yeah. So Regina says, please explain the concept of regression and correlation. I think you joined later. I started with those already. There is a live, I'm live currently on YouTube. So there's going to be a link that I'm going to share on my bio. So you can go and click and go back and see some of the stuff that I have spoke about already, or if you have missed something. That is why we are doing hybrid. We are going hybrid now and moving forward. Now we have got what we call something that is very important for data analysis. It's called inductive and deductive analysis. What does it mean? Inductive simply means data, the structured direction is data, then codes, practice, patterns, and themes. The analysis is substantially driven by pattern emerging from the data. So while you're analyzing, look at the pattern that is coming up, then you do that. The deductive looks at this direction, existing concept or framework, data, coding, and analysis. So this one is normally guided by predetermined concepts, theories, research question, or analytical frameworks that are already there. So that's where you go, for example, for something in IT, maybe a concept that is there, maybe a BIM, or you can also look at other VUCA as an example. You can also look at other, established frameworks or concepts such as, for example, I can't get anything on top of my head right now, but those are the things that they are very important for you to do. Okay, so something here that says I must do this unless life will then end in the next four. I'm not sure if um and what do I need to do. Okay, let me see. Okay, now I think I managed to do it. That's fine. um so it's very important for you to also, when you are doing your when you are working with your research, to understand the difference between inductive and, I mean, inductive, sorry, and deductive. Okay, then we have got what we call hybrid, which combines the two. So many studies, for example, combine both. The researcher may begin with theoretically informed category while remain open to unexpected patterns that might come from the data. So it's very important for that. Now we've got what we call um, trustworthiness in qualitative research. Very important. It looks at the issues of credibility, dependability, conformability, transferability, and this is qualitative open is often discussed within the trustworthiness within those couple of things that I just mentioned. So it's very important for you because for validity and reliability, we will then have to look at those possible strategies for you to capture all these things. Include audit trails, for example. What have you done? The procedure and the process you followed, reflexibility, for example, triangulation if you used it, member check-in, for example, where appropriate, rich text, for example, description, um, transparent coding procedures, peer or debriefing procedure where appropriate. So it's also interlink with some of the stuff that you do. So don't merely list or go and list some of these things um, on without explaining how does the study actually apply them, because most of the students will just go and define what is credibility, what is dependability, what is conformability, and what is transferability without giving us or including audit trails, for example, reflexibility, triangulation, blah blah blah, that you might have used, that will have included the strategies within the credibility, dependability, conformability, and transferability issues. So you don't just define, you only have to make sure that these are aligned to your study and explain how those things were applied in your study so that the validity and reliability can be trusted within for your study. So we've got the mixed method data analysis also that looks at um, the qualitative and the quantitative coming together. And remember, I spoke about the four types of design that are found within the mixed approach. So I won't keep mentioning them because I've mentioned them. But for the benefit of those that joined, I'm referring to the convergence parallel method. I'm talking about exploratory sequential design. I'm talking about explanatory sequential design, and the last one that deals with the others being the complementary of the other, and then integration. So a useful formulation in data analysis that you do in mixed approach, depending on the sequence or the type of um, design you have chosen or that is relevant for your study, you always have, for example, qualitative plus quantitative plus integration, which gives you a mixed method interpretation. Or you can start with quantitative, then qualitative, and then integration. Or you can start with qualitative, then quantitative, plus integration, depending on the design. So I think I've dealt with a couple of things which are structurally supposed to be like that. And I'll jump straight to mixed method design for analysis, for example. The convergent design, we're looking at um, quantitative analysis, interpretation, then qualitative analysis. So what I mean by this in terms of the convergence is, remember, the convergence is they start together at the same time, so they are parallel. So it doesn't wait for the other. It starts immediately. So both strands are analyzed and then compared or merged because it's a convergent design. Then when it comes to a explanatory design, explanatory always start with quantitative phase. So it's quantitative phase, analysis, then qualitative explanation, then integration. You get the design and the analysis. I mentioned this, but I'm just reframing them so that you get to understand them. Exploratory, again, um, qualitative findings that, for example, in exploratory sequence, which is um, qualitative analysis, then quantitative, then testing and extension, then integration. Then the qualitative finding initially explore the phenomena or the phenomenon that is under investigation and may inform subsequent quantitative component that will be there, because that's the first phase. So the first phase is grounding the study, and then you can even go and tweak or iterate or put something that is relevant, because some of the subsequent component of the quantitative may be derived or maybe by the issue or the relevance of um, the analysis that you did on your qualitative data. So the integration technique that we have got what we call merging, which brings qualitative and quantitative findings together. We have got connecting, which results from one phase determine the participant or question or data for another phase. So if you have started with qualitative then gives you how your rephrasing of questions will be, for the next phase. And then the building, which where one data set helps develop the next instrument or analytical stages. And then you have got a joint display where qualitative and quantitative findings are deliberately presented together. Um, Alignment, which is most important. So your analysis must always answer your research objective. If they don't answer your research question, something is wrong. What is the logical direction? The logical direction look at the research problem, it looks at the objectives, it looks at the research questions, for example, it looks at the data collection. From data collection, then you go to data analysis. From data analysis, then findings, conclusion, and recommendation. So it's very important for you to look at your objective so that you can, from the objective, especially not necessarily from the objective, you need to start from your research question, then come to your objective. And then the last part that I can talk about is just softwares that are used, for example, for qualitative, because I haven't mentioned them. The common software that I use for qualitative is NVivo, Atlas. There's another one that is called MaxQDA or MaxQDA or whatever you can want to call it, and a whole lot. So those are just an example of that. And of course, on your quantitative, you've got your SAS, you've got your eViews, you've got your Excel, you've got your Python, you've got your Stata, you've got the SPSS, you've got R and Power BI and the rest. So there's so many that you can talk about. So SAS is one of the softwares that are used to analyze the data. Okay. So importantly, remember, SPSS does not necessarily have to, it does not decide which statistical test is appropriate. It's the research objectives and the research question that determine the correct and appropriate research questions. Of course, NVivo also doesn't also determine thematic analysis for you. The thematic analysis is determined by the research questions and the objective of your study. So results versus finding versus discussion, which is something where many students don't get it. Even lecturers, most of the lecturers, sorry to put lecturers under scrutiny, but even lecturers sometimes don't understand the difference between the results versus findings versus discussion. Results, what is result? Results is what did the analysis produce? That is result. So if you do a statistical test, you come up with the test or whatever, those are the results. Okay. Findings. What do findings or what does that result reveal in relation to the research question objective. That is your findings. Now, after you found that, after measuring the frequencies, or if you have done ANOVA, or you did correlation and you did regression analysis, an example, you found some digits, some numbers, and everything. Those things are your results. Then your findings is what reveals, what does this results reveal, and immediately you get that right, then you know, in relation to your research question or an objective, then you get it right. What does discussion mean? Discussion simply mean, what does the finding mean in relation to the existing literature? That is why the discussion must always be referenced, because that's then now you look at what you wrote. Remember, you wrote your knowledge, the existing knowledge in terms of literature review. That's now where you go and argue and say, these results, in terms of the findings, are related, now this is your discussion, are related to the study, or collaborates with the study that was done by Sean and Clark, or by Cresswell and Cresswell, or by Malapane, or whatever you can come up with, or whoever was the author, because it has to be relevant, it has to be on point, and it has to be supported by the literature. That is what discussion is. Results is your transcript. Results is your statistical test. The findings are, what are those things? What do they mean with relation to your research question or objectives? And then discussion is, you will now link the findings, what you found, with the existing literature. Okay, let me just check if there's a question related to these. Um, Alrighty. We are about to finish our structured session, because for TikTok, I mean for YouTube, I want my lessons to be limited to an hour so that they are stackable and proper. You don't want to sit in a lesson for more than 3 hours whatsoever. We can come back and talk about anything else, and we can do that. Building a master's says, hey, I need your help. Yeah, take my number on the screen, or DM me here on TikTok. We can take it from there. Common Common mistakes that are made during data analysis by student. One, choosing an analysis before understanding the research problem. Two, treating NVivo or SPSS or any other statistical tool or qualitative software as an analysis method. Presenting, for example, percentage without interpretation. Running statistical tests without checking assumptions. uh, sorry, confusing correlation with causation, reporting p-value without effect sizes or substantive interpretation, creating qualitative themes directly from um, interview questions, for example, presenting quotations without analyzing them, producing too many meaningless codes or themes, claiming, for example, themes that emerge without explaining the analytical process. And of course, conducting qualitative and quantitative analysis separately in a mixed method without integration. And of course, reporting every software output table. You can't. That's why we've got results, we've got analysis, and then you've got discussion. And making, for example, recommendation that cannot uh, be traced to the finding. So it is very important for you to understand, um, and just don't say, I'm going to use regression. Just don't say you're going to do this. It must be relevant and related to your studies. All right. So for you to memorize, as a parting ways, for those that will be watching on YouTube, because that's why I'm stopping for YouTube, you got to understand, for example, if you're exploring, or you explore experience, that is qualitative analysis. If you determine the relationship, that is correlation or regression, depending on the question. Somebody said, I still find it difficult to differentiate correlation and regression. I'm giving you an example now. Determining the relationship, it means that is correlation or regression, depending on the question. Comparing, for example, group A and B, uh, group comparison test without necessarily, you need to understand that comparing group A and B is appropriate for group comparison tests, where you determine whether X predict Y, that is regression. Correlation, remember, is all about the relationship And then um, whether X predict Y, that is regression. Understanding, for example, perceptions is qualitative analysis. Determining association between two categorical variables, that is chi-squared. Okay, comparing three or more, I said is what? ANOVA. All right. So it's very important for you to understand these things. And at your master's and PhD level, it's very important to differentiate, to understand these things and go. What are the key takeaways, or what are the final key takeaways? Remember these 5 rules in data analysis. Your analysis must answer your research questions and objectives, full stop. Your data type determines what analysis are possible. Software is a tool, not a statistical method. I gave you statistical method, and I gave you the difference. Reporting the result is not the same as interpreting findings. And also a mixed method, when you're using mixed method, integration phase is essential or is key. So good data analysis, guys, is not about showing how complicated your statistics or coding is or can be, but it is using the right evidence and the right analytical method and defensible interpretation to answer a research question or to meet a research objective. Again, my name is Dr. Alex Malapane, and thank you very much for joining us tonight. So, those who are on YouTube, if you want to get hold of me or you need help beyond this, please take the number on the screen, or you can write it down, 079 or you can send me a DM on TikTok. You can go on TikTok and follow me and look for me. Dr. Bay is my username. You will find me and look at this big head. You will recognize me, and then you'll be able to then contact me, and then we'll take it from there. Thank you so much for watching. Until we meet again, for those that are watching on my YouTube. Alrighty, so for